Okay, now for similarity theorem, it is said that the corresponding sides of two equiangular triangles are in the same proportion, and therefore the triangles are similar. So we have two triangles, ABC and DEF, and then angle A is given to be equals to angle D, while angle B is equals to angle E, and angle C is equals to angle F. So these two triangles are equiangular. So if that's the case, that means that the proportional sides A, B over DE will be equals to AC over DF, equaling BC over EF. If we can prove that that's the case, then we say the two triangles are similar. So that is what we are required to prove, that the proportional sides, the sides are in the same proportion. All right, so let's start. So with our proof, we're going to start with a construction as always. So let's start with a construction. So construction. So what are we going to construct? So we're going to say on AB, on side AB, we will mark off, and then we will have AG being equals to DE. Okay, so we are going to have a G in the middle of side AB, and then an H in the middle of side AC, and then, H, and H on side AC. We will then join GH. Okay, so we are saying that we will mark off that AG be equals to DE. So that's what we're going to do. AG will then be equals to DE. Further, we're going to say on AC, we mark off AH is equals to DF. So then we will make AH being equals to DF. And then we also have joined GH. That's our construction, making point G on side AB and point H on side AC. Then we join GH and then mark off that AG is equals to DE, and then AH is equals to DF. So now we can prove. Okay, so after the construction, we're going to now focus on first the two triangles AGH and triangle DEF. So we will say in triangle AGH and triangle DEF, what's the case then? We know that AG is equals to DE. Remember, that's what we constructed. So we can say constructed. And then also, we're going to say angle A is equals to angle D that was given. This is an equiangular triangle. So we're going to say angle A is equals to angle D, and this is given. And then thirdly, we will then argue that AH is equals to DF. That is what we constructed. Okay, we say AH is equals to DF. That is what we constructed. Great. Okay, so at this stage then we realize that, okay, therefore triangle AGH is congruent to triangle DEF. What is our reason? Because we just proved side angle side. Since these two triangles are congruent, therefore angle G1, okay, let's name this G1 here, this angle G1 will be equals to angle E, will be equals to angle E. So we're talking about these angles here. Angle G1 will be equals to angle E. Okay, so remember the focus is on triangle AGH and DEF, and we just proved the two to be congruent, therefore the remaining angles are equal. Okay, but if you remember, it was given that angle B is equals to angle E. Yeah, it was given that B is equals to E. B equals to E, B equals to E. Okay, so since both G1 and B are equals to E, therefore they are equals to each other. Therefore, angle G1 is equals to angle B. Great. Okay. Angle. So we just proved now that G1 is equals to B. Look at that. That is an F. That is an F. So these are corresponding angles. That would mean then that GH is parallel to BC because we have two corresponding angles that are equal. Great. So we just then showed that GH is parallel to BC corresponding angles are equal. Okay, therefore, and then what's the case? What do we know if those triangles are then parallel? If these triangles are parallel, then we know that AB over AG can be equals to AC over AH. Okay, so that is from proportionality theorem. Then we know that we can say AB over AG is equals to AC over AH. All right, and then if you remember, we did say that AG is equals to DE and that AH is equals to DF. So we're just gonna replace them there. So therefore, AB is equals to DE because AG is equals to DE, and then AC is equals to AC over AH is equals to DF, so we replace that AH with DF. Okay, so yay, we just proved the first part of that theorem. So how do we go about proving the third part? Very simple. Since we're going to follow the same steps, we're just going to use the word similarly. We would just use the word similarly by constructing B BG and oh, what just happened? Sorry about that. By constructing BG and BH on AB and BC respectively, we're just going to, so this means that we definitely just following the same logic. Okay, so let's construct. So that means we would still have our triangle ABC and the corresponding angle DEF. Same story, this A is equals to D, B equals to E, C equals to F. They're still given, but now our construction is now focused here. G is still on AB, but now H is on BC. Okay, we will say BG is we're marking off BG with ED and marking off BH with EF. So you will see that we're following the same logic. If this is the case, since we use the word similarly, following the same logic, that would mean that AB over DE is equals to BC over EF. Okay, so if we follow exactly the same logic, that's going to happen. So there's no need in mathematics to repeat the same steps when you're proving something. If you're going to follow the same logic, then you can just say similarly. All right, therefore then we know that AB over DE is equals to AC over DF, which is equals to BC over EF.